Hi, good morning, and welcome to the ZP Developer Zone. So we do this webinar every Thursday at 8 a.m. London time. As some of you kind of regularly come here, you can see I'm in a different location. I'm at a hotel. So my apologies for the internet or any dropouts, etc. It's a little less under control. Let me go forward because as per normal, super busy with A, work, and B, inquiries and answering technical questions, but we do appreciate the technical questions. I think they're really kind of they're useful both ways. You know, we answer questions and we also learn through the questions. It's quite useful. So we do have the ZP Academy if you're looking for free advice or sort of free learning on electrochemistry. There are at least 2 free courses up there, so I really recommend those. We do have the webinar, so you know if you're a customer or a client of ZP, then obviously you know these webinars. So for example, we had a really good client of recent who's come in from Asia. They've bought a lot of stuff off us, and because of that, you know, we were able to offer a kind of complimentary ticket to one of our workshops. You know, because they'd been so significant, and they were, you know, it was a nice interaction. Let's put it that way. We do have collaborations. So I happen to be, we have an office in Swansea. I have an office on the campus. An office. It's not the only one we have, but I'm at Swansea in South Wales at the moment. We do have lots of collaborations, for example, here. In fact, we have hired 2 new hirings recently, and we do have our ZP Developer Zone and workshops. Not every question is a simple 3-minute answer in a webinar, and you know we either do more webinars around the question, or one of the most efficient ways of meeting ZPs and interacting with us is through our workshops. If a link pops up, I've already put it underneath the video. So I will sort of, how do I say that? I will go fairly quickly at the moment, but we do have all these workshops, you know, and in those workshops we do cover impedance spectroscopy, gold electrodes, carbon electrodes, immunoassays. These are topics for this week that we'll discuss. So we do have a lot of them, and in fact this list just got longer because we do have one now in November as well in Norway. This, you won't see this again. This is our Scandinavia Sensor Summit, so we do have a you know, the future for either health, well-being, environmental, agriculture, aquaculture, industry. The future for it is actually sensors, and if you're watching this webinar, then you probably feel the same way as us. It's actually electrochemical sensors. So we're holding a conference around digitization for a sustainable future. We're really kind of saying that, you know, sensors it should really be at the heart of everything. If we can measure it, we can improve it. If we can measure it, we can control it. So we're all about sensors and measurement systems at ZP. And this conference is going to happen next week, so we'll be super busy then. But we'll also do one next year as well. Just get into questions. Question number 1: how to connect between Metrohm potentiostats and ZP electrodes. So a couple of things. ZP makes a really good electrode. I've said it before and I'll say it now, and I'll try and say it quickly. The reason ZP makes a really good screen printed electrode is because we use them. We absolutely use them. If you ever Google food sense, you'll see that ZP uses its own products in B2C products. So B2C means sort of business to customer or business to consumer products. We use those electrodes in those products. I think we're the only, we definitely are the only manufacturer of screen printed electrodes who truly uses their own product. Right, so I'm going to talk about how to connect between the Metrohm potentiostat and ZP electrodes, because I know that people get electrodes from other places, and the one thing they really complain about is the repeatability of these things. From electrode to electrode and from batch to batch, there's a lot of repeatability. I really enjoy this interaction that we're having with a designer really of, he's designed a free potentiostat, an open source potentiostat. There's nothing free, you have to put your time into it. But we're just sort of having an online conversation about EIS experiments for teaching labs, impedance spectroscopy, which is really relevant because today actually, you know, I think I've had some inquiries about making immunosensors on gold electrodes, and impedance spectroscopy is something that we like to use in that kind of application. I am frustrating somebody slightly, and I apologize for it, because they're asking for a certain type of gold electrode and I keep recommending another type of gold electrode. So I sort of apologize for that. ZP is a little bit different because I think you can go to many companies and you'll tell them what you want. They say, yeah, here you are. But at ZP, if it's involves electrodes and it involves electrochemistry, and it probably, we always have an eye on commercialization. It's funny because I get it. People say, I want this. And I say, look, will you please take this? And they're like, why? Because, with all the experience, I started my career, 2000 after the PhD, at places like Abbott making glucose sensors, all that experience now that I've gained. I try to kind of guide people towards what I think will actually get them onto the market, as opposed to just, yes, you can have this part. And I'll explain that in a little bit more detail. Immunosensors on gold electrodes, no problems. We do this all the time. I'll discuss it. And then the last one that came in, and just give me a quick, I had to kind of scramble to do this one. Somebody wanted to detect uric acid on a handheld device. And I will discuss that as well. And I suppose what I can say is, if you're watching this webinar, if you want to make a single analyte on a handheld device, ZP has a platform now called SenseIt that can achieve this in 3 months in a minimally viable product. It's called SenseIt, very quick way of achieving MVP, minimally viable product, and it can also go on to be your product. So integration with Metrohm make a potentiostat. They've been around. Metrohm bought a company called Autolab. The instrument is many years old. It's embedded in a lot of places. I did put a bit of a landing page about how to connect between these, between what they have and what we have. It's not something I'll support, but we do have a connector, which I describe here as a sort of 7mm connector. So that's the sort of, when I recommend electrodes, the width of our electrodes is, or screen printed electrodes, is about 7mm, the banana plugs on a Metrohm potentiostat are about 4mm. So this is essentially the glue between their cables. They have banana plugs that end in about 4mm, and ZP connect screen printed electrode, which is about 7mm. So I put a little link to that as well. Obviously, I would say biased in a good way, to be frank. We obviously do make our own potentiostat. In fact, I think I've got a link to it as well. I can absolutely recommend this potentiostat. We use it all the time. It's 6 channels. It's tiny and it's 6 channels. And the reason it's powerful is because if you've got a potentiostat, especially a lot of potentiostats, the Auto Labs, etc., they're good instruments, but they're super big, and that's okay. Footprint. Maybe you've got the footprint for it. But they're often single channel, or if they're multi-channel, they're like 20,000 plus euros, dollars, pounds. So we make a really small potentiostat at a really competitive price, and it's actually really quite great because we're the ones who use it all the time. What makes ZP products quite remarkably different is we're the biggest users of our own products. So it's like going to a restaurant and you find the chef out in the front eating away, and then that's always a good sign. So we are, and I am enjoying this interaction. I do like interactions with smart people. So somebody wants to bring impedance spectroscopy into their kind of teaching labs. Impedance spectroscopy is an important science, especially if you're making immunosensors. This is a sort of protein immunosensor that we've made in the past. This is 3 electrodes. This is 3 screen printed electrodes. They've all been functionalized with antibodies to be specific to the target. So they're all, I'm really kind of pleased with this result. Each color here is 3 electrodes. So it says something about the repeatability of manufacturing. And so later on, well, one of the highest inquiries we get is, I've been using X electrodes from X company, and my problem is repeatability. Well, at ZP, we don't have that problem with repeatability, and this kind of immunosensor on one of our gold electrodes actually demonstrates that we're able to get, these are essentially manufactured screen printed electrodes, but we've then manually functionalized them, and it's several layers. There's at least the sort of a coupling chemistry went on there, then the antibodies went on there, and then some blocking materials went on there, and there was some wash steps. So quite a lot of processing, and yet we still got this repeatability, and that's because the underlying repeatability of our screen printed electrodes is so good. At ZP, we kind of describe ourselves as sensor to API, sensor, which, if I could sort of rephrase it as well, sensor to cloud. And that's technology stack is really quite good. You've got screen printed electrodes, electronics, web apps, cloud system. We've got all that in place, and we use that to get our clients essentially to market. But it all starts with the electrode, because if those electrodes are not repeatable, it's basically you just carrying a whole bunch of rubbish all the way through to the cloud. So, it's really important for us to get repeatability. Sorry, I'm talking fast, but you'll find that a lot of these questions are actually connected. So, happy to support this guy on SPE. I am hoping that he will use our carbon's hypervalue electrodes. To be fair, at the moment he's not, but within the kind of the idea of community spirit, I'm definitely supporting him. And I support, we support people through these kind of webinars. So I did make some recommendations. I said, look, you're going to go into a teaching lab, or you're rather going to have a teaching lab, so get the students to make up these kind of 3 solutions, which we covered last week, and I sort of gave him some instrument settings. This guy's smart. He doesn't really need my guidance, but there you go. It's probably nice sometimes just to have a sounding board. And I had a bit of an idea of what was going to be happening. By the way, this is all covered in our workshops, that I was telling him to kind of use ferrocyanide, and that there was going to be this kind of oxidation to ferricyanide, and he will know about equivalent circuits. And I really like impedance spectroscopy, because it allows us to deconvolute a complex signal and actually understand lots of parts of the total signal, and even assign them to specific events. So I was predicting that his charge transfer resistance would decrease the more ferrocyanide he added. That was my kind of logic, let's say, behind it. And I sort of, I found a literature precedence for this, that essentially this is what's called a Nyquist plot, and this kind of semicircle on the Nyquist plot got smaller, which I indicate here, as the chemistry essentially becomes easier, and I'm sort of arguing as the charge transfer becomes easier. And he sent me some data. Now we don't see the beautiful semicircle. This is a kind of the leading edge of the semicircle, because he hasn't quite gone to, I think, low enough frequencies. No criticism of him. It's fine, to be honest with you, because if I was doing a product development, I want to make quick assays. So sometimes I don't want to use low frequency. Low frequency will give me a beautiful Nyquist plot, and I can publish it. But low frequency also then, if for a user experience, means that the person's waiting around while you collect data. But when I look at this, there's a strong enough signal. This is just 1 molar KCl. This is 1 molar KCl plus 1 millimolar of the ferrocyanide. And this is 1 molar KCl plus 5 millimolar of the ferrocyanide. It's clear. You don't need to do deconvolution into an equivalent circuit to see that signal. That's perfectly good. So at ZP, we kind of take a sort of a non-purist approach to this. We can either deconvolute it and do the whole equivalent circuit, or actually we could just say, well, there's the signal. We could literally sort of choose one of the frequencies and prove that frequency was proportional to concentration, and then we're sort of good to go. So I understand the work. It is exactly the way I was expecting it, and it's basically this charge transfer resistance. You are decreasing it as you increase the ferrocyanide concentration, and I can see you've sort of developed your own software around this. What we're going to do is, I've got one of the engineers uploading your data into Julie. So Julie is a cloud system. We had a webinar on the 4th of September. Anyone who's following along this morning, that link will be underneath the YouTube channel or the YouTube video. Watch it. And then we got another one on the 24th of October. So I just want to say to the gentleman who's asking me about this, we're going to upload it to Julie and actually do your equivalent circuit modeling up in Julie. So we'll probably have dealt with that by next week, and we can cover it then. This one I do apologise, because I know the guy really wants to get some gold electrodes off us, and people really like these circular electrodes. I get it, right? The reason they like it is because they can kind of pipette on there. It's classic because there are companies out there that make these kind of gold disc electrodes, which I think are I can't even remember the diameter. I think it's about 4 millimeters. So people do like these electrodes, but they're just kind of almost like historical is too long a word, but they've been around for a while and people are quite familiar with them. The reason I don't recommend them, and then the reason that we is because they are quite big objects. Now, a big object means that when we're doing either roll-to-roll printing or doing screen printing in sheets, your density of manufacturing is lower. So that means that I don't think is a strong word. Sorry, think is too weak a word. I think I know. These kind of electrodes will not scale well when you really want to go to market. So I don't like the size of them. And I also don't like the shape of them. Now, the reason I don't like the shape of them is invariably people end up putting these kind of systems into what I call an IVD, an in vitro diagnostic. And in an in vitro diagnostic, you have flow. You put a sample in, the sample gets through a sort of microfluidic channel or microfluidic device, or call it a point of care diagnostic. And so the geometry that we have designed is really compatible with flow. So the reason I sort of sometimes make recommendations, and maybe I feel a bit frustrating, is because I'm imagining where you're actually going to put this product and what your end goal is. So these circular electrodes are all very fine for, a sort of academic R&D effort where you want to just think about just the sensing layer itself. But when you're really thinking about the total product, then that's why I'm then recommending our gold hypervalue electrodes, because they're smaller, they're lower cost, they're designed for microfluidics, and importantly, we make a lot of them. So if you want repeatability in electrodes, and repeatability is a big it's basically a need, and then you need to be using a platform that is being made in quite high volume. So ZP makes a lot of these hyper value gold electrodes, and therefore our quality systems in place. They're made not by batch wise, but they're continuously made. So I do recommend these hyper value gold electrodes for a reason. We will do the other ones, but we will only do them in large batch. And if people want small batches, I just say come onto the hyper value gold electrodes. I know it's frustrating, but it's not. It's because in the end we really want to back with people who really want to get to market, and so we do kind of give quite strong recommendations. This question is really about building a immunosensor on gold electrodes. Obviously, I do recommend our hypervalue gold electrodes. I know it works in immunosensors. At any one time, we've always got, at the moment, we've got at least 2 immunosensor programs in-house. I mean, our business model is we're ISO 13485. We do contract development, contract manufacturing of electrochemical biosensors. I'm kind of doing verbatim here on what it says on our ISO standard. So we do a lot of this, and at the moment we've got at least 2 programs on when we try to make immunosensors for, one of them's for a pathogen and one of them's for a inflammatory marker. So we do it quite a lot. It's probably worth saying that when you're trying to make an immunoassay, there's a kind of interaction between the method and the sensor. So if you come to one of our workshops, we do cover impedance spectroscopy quite a bit. And if I could just give a quick recommendation, if we were doing an immunosensor or immunoassay on, let's say, a gold electrode, and carbon electrodes, I should say, we would be playing with EIS, impedance spectroscopy. We quite like it. We have also done differential pulse voltammetry and square wave voltammetry. It's probably worth saying that we have something called the Sense It All platform. So any of these techniques that we would otherwise try in the lab, it's not even an effort to just translate them onto a handheld device. It's no issue for us at all. And I just had a question actually, and I've never seen this question before. Is the participation in this webinar receive a certificate? That's a good question. Reach out to us at Zimmer and Peacock contact, because I'd like to discuss that. It's actually quite an interesting idea. So somebody's particularly interested in gold electrodes. We use a lot of self-assembled monolayers to make gold electrodes. I do recommend that, this is an unusual thing, I do recommend people to actually use carbon electrodes. You have to change the coupling chemistry. The reason I recommend carbon is, if somebody asks me, well, I've got the choice of using platinum, gold, or carbon, I always say go for carbon every time. Why? And it's really, it's the compromise between performance and cost. Platinum and gold are expensive. They've always been expensive. They're never going to get low cost, whereas carbon is pennies relative to gold. So I can't over recommend that If you've got a choice now at the beginning of your program, go for carbon. It's going to give you a much lower cost electrode. I mean, I think it's fair to say that we're selling the hyper value carbon electrodes. If you buy a sheet, and it's a sheet and it's perforated and there's 300 there, it costs about 250 euros. So it's less than a sort of euro each. Whereas the gold ones, I think, are about €6 each. And everything's the same apart from the change of gold. It's gold. It's really expensive. I really would keep off gold. The only reason gold is used quite a lot is because a lot of people kind of inherit self-assembled monolayer chemistry from a paper or something like that. But I'll show you an alternative way as well. Few useful links here. I'll already put them underneath the video. So So take your gold electrode, MCH that we're using here. You can then activate this carboxylic acid using an EDC NHS coupling. I'll just drag my face out of the way. And then you can basically add your antibody, and then you can block with something like BSA or chitosan. I mean, we do this basically works. I mean, and what's nice about the ZP is that we follow the process by something like cyclic voltammetry, so that every time we functionalize the electrode, we can see the change in the electrode, and then it makes it sure that we're actually following that. I would say that anyone who's embarking on immunosensor chemistry, the first time you go through it, engage with Zimmer and Peacock to do a proof of principle study. I think you'll save yourself, well, in the long run, hundreds of thousands of dollars, if not maybe $1 million, because we'll get you on the right path before you essentially go too far into it. So here's a bit of chemistry that we use quite a bit to make immunosensors. I used to recommend our value gold electrodes, but now we made a hyper value gold electrode, so I would absolutely recommend the hyper value electrode. I may have forgotten to put this link. This paper is free for download online. It's something that I worked on quite a few years ago, but it worked quite well. And so take one of our hyper value carbon electrodes. You use this kind of pyrene NHS molecule. So the pyrene is really good at bonding to the carbon surface. And then we've got this NHS group, which is quite reactive. And that's where we can kind of couple the antibody to, and we can block that surface with something like chitosan. As I say, there's only one question that's come in this morning, and somebody was asking about a certificate for attendership, and that's quite a good idea, actually. So if you reach out to us via the website, then I think we can have a conversation about that. So you can functionalize these electrodes by following that original paper. We like to follow each step of the functionalization using cyclic voltammetry, because we end up distorting the CV, which tells us that we are blocking, well, not blocking, but functionalizing the surface. The testing is also covered in the paper as well. These days I would obviously recommend our EMA potentiostat rather than the potentiostat that we used at the time, but I am biased. And every time we were able to then add the target, in this case we were using differential pulse voltammetry, the magnitude of the signal increased, and it really worked out quite nicely. And this is a piece of chemistry that we use quite regularly. A proof of principle with us means that, if we can understand what the target is and the antibodies or the aptamers or the recognition molecule already exists, then we can generally do that kind of work in at least get to sort of first calibration line in about 111 hours. Whether you go on to do further work yourself or you leave it with us, it's kind of up to you. The last question this morning came in fairly late, and I've sort of scrambled to do it, but detection of uric acid. It's probably worth saying that at this moment, ZP probably has 39 electrochemical sensors on its website. We actually have more assays than this, but let's say we have 39 electrochemical assays on our website. So it tells you something about the ubiquitousness or the usefulness of electrochemistry as a modality for detection. And one of the ones that we have is, I did put a link to that page as well. One of the ones we have is uric acid. And any of our sensors will actually work with our platform called SenseAll. So hopefully I've put some links to Sense It All. But Sense It All is this is a Gen 3 product. We're actually on a Gen 4 product now. Sense It All says I have a sensor, or ZP has developed an assay for me. I need to I need to have some tangible hardware. I need to show progress, because so many projects just get stuck in the kind of science phase, but ZP has actually figured out the whole engineering phase already, and then you can just move the science onto the electrodes, and then we've got the rest of the platform sort of worked out. So at ZP we have the electrodes, which become sensors. We have the electronics. This was the G3. We're now on G4. We have app. So we have an app platform. If you follow any of our webinars on this, you'll actually find out that this app, we can just change the functionality of the app by just using a QR code. So it's really easy to implement your logo, your method file, and probably your algorithm. We obviously have cloud, so we have something called Julie. And so that, in fact, it's really useful, because if you're working with us, then your data goes to Julie, and you can allow us access to look at that data. It also means that if you've got sort of clinical people that you're working with, they could be gathering data on real samples, and the raw data, not the patient ID. I understand about you can't put patient data into, necessarily just into the cloud, but the raw data will go into the cloud, and it really helps you with knowing where your data is, and with your really with your development cycle, because you can look and make sure that the data that's coming from the clinic is actually good. So we're able to kind of give the result in real time on the smartphone, and we're able to get the raw data into the cloud as well. So it's a real, I suppose I started off on about slide 2 by saying, ZP makes a really good electrode, but if you really look at ZP, we're sensor to cloud kind of company, and even sensor to API, which is application program interface, which is a way of you getting data from our cloud into your cloud. And this is the sort of back end of it then, that, most of the conversation today has been about electrodes, probably carbon or gold. Then the conversation's been about impedance spectroscopy, which is one way of getting signal out of an electrochemical sensor. And I did touch upon differential pulse photometry as well. But those are all kind of the lab side of things. But how do we actually make a first tangible product of this? Well, it's really quick with ZP. We have had clients come to us at Christmas time, and 3 months later they were demoing a minimally viable product in front of their investors. And I suppose that's what makes ZP different. The question that you may be asking yourself is thinking to yourself is, I've got a technical challenge. But often the challenge you have is actually financial. You need to hit milestones so you can release the next round of funding. If you want to interact with ZP and sort of understand some of our business acumen, and also get to understand some of our technology, then I just go up slightly. Then do come to one of our workshops. There is a big conference next week, but I realize that's a little bit late at this point. And I want to say basically thank you. So now, if I haven't completely answered your questions in this webinar, reach back out to us, because most of these questions have people already made personal contact with us through the website. And if we're not giving enough answer, just reach back out and we'll try and add to it next week. You can engage with ZP in a sort of private consulting as well. That exists, and we charge out by the hour for that as well. All right, so I will basically say thank you very much. The person who did ask about the certificate for attendership, I think that's a good question, and reach out to us on that and we'll talk about that. Okay, thanks very much, and have almost to the weekend, so have a good day tomorrow, and then the weekend is here. Okay, take care, bye-bye.